Hello, fellow web nerds. It is I, Jared, here for the Spicy Web. Today I'm going to talk about signals. Yes, that topic that everyone is talking about, keeps talking about. But it's a very exciting time for fans of signals because there's a new proposal out to add signals in some form to the native web platform. So I thought it'd be interesting to look at just what do signals give us in terms of authoring reactive components. And it'd be fun to take a look at Preact signals as one of the popular implementations. You can use the signals core library from Preact in any framework. You don't actually need to use Preact. But here I thought I'd actually use Preact to kind of illustrate like what's sort of the older paradigm if you're familiar with React or Preact using hooks and so forth in your functional components. And what's this new paradigm of signals and why is that exciting? And if you're interested, as I am, in authoring more vanilla sort of JavaScript and web components and so forth, can signals really help us there? I think so. So let's take a look. All right, so bear with me while I just fill out some boilerplate here. We're first going to import Pico, which is a very nice little minimalist CSS framework just to make things look nice. And I'm just going to paste in some basic HTML here to get things started. So counters in Preact. We're going to first start with the bad counter and then go with the good counter once we add in signals. All right, so first we're going to import Preact and Preact hooks from esm.sh. It took me a while to actually figure out just how to write this out in a way that works. So you'll thank me later if you want to do some demos of your own in CodePen, because this was not obvious. Anyway, let's go ahead and write our bad counter component. All right, so we'll start out writing function bad counter. And inside we're going to write our, pretty bog standard state hooks. So we got a state. We're also going to set up double as a memoized function here, right? We got to include that dependency array. So only if the count changes will this memoized function rerun, because we don't want to run every time. Rule of hooks and so forth. And strictly speaking, this isn't necessary, but we'll be good citizens here in React/Preact world and write a callback for our increment action. I'm just going to increase it by 1. All right, so far so good. Now we got to return some markup, and we'll write in bad counter. Why am I getting this? Sorry, I just had to turn on Babel for the JSX processing here. So a little bit of a visual glitch there, but there we go. Now we're not getting any errors. Let's continue. All right, and we should probably go ahead and write in our render function here to add this to the page so we can start seeing what we're typing. Fix a typo. It said use menu instead of use memo. There we go. All right. We are back in business. So now we have some display here, but we got to go ahead and add our button. So let's do that. All right, got an increment button, but obviously clicking on it doesn't do anything. So let's go ahead and fix that. There we go. Okay, I'm clicking the button. It is incrementing the count. It is getting the derived value there, which is ×2. All right, we have our basic little counter. But, as you can see, it's a little bit messy. We have to bring in use state, we have to bring in use memo, and then we have to pass count into use memo. And then here we are using use callback and passing in count. And this is for performance reasons because, as we all know, when you write a component like this in React or Preact, the function re-executes like all the time. Like every time I click this button, so there's a state change, this entire function re-executes. And we can prove this by adding a simple console log here. So let's go ahead and do console log, bad counter, re-execute. We'll pull up our console here. And watch what happens. Click. Bad counter, re-execute. Click, 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 click. We can clear this. Click, click, click. Every time I'm clicking the button, the entire function reruns. This is how functional components in React and Preact work. We're all used to it, but I think it's important to note that this is non-obvious to someone who has not been familiarized with this concept. And, well, after many years of writing functional components like this in React, still not a fan. Still not a fan. You know, it might not be, you know, that big of a deal for this one little function, but, you know, if you multiply this by thousands of functional components across, you know, in a web page, navigating across multiple pages, there's a lot of code executing in the background, right? There's just a lot of stuff in memory. You got VDOMs all over the place. Functions are being re-executed all the time. And, you know, I think if you're very experienced as a programmer in this paradigm, you can, you know, really optimize things so that that's not really an issue on a lot of applications. And, you know, if you're working at Facebook using React, you have that experience. But I've seen lots of performance issues with React because it's just not obvious that your functions are rerunning every single time. So what can you do about that? Well, that's where signals come in. Let's write a good counter with signals and compare these two approaches and start to realize kind of the way the mental model shifts with this new approach. All right, so we're going to pull in signal, use computed, and use signal effects. I will explain all of this in a minute. And now we'll go ahead and write our good counter. Okay, we'll start with use signal. Instead of use state, we have use signal, and we're pulling in count. Now count here is not an integer, it's a signal, and we'll show how that's used in a moment. All right, so now we're computing the ×2 value of our count, and now you can see we're writing count.value. All right, fix that typo. We have count.value, and that's basically the API of a signal. You have .value because count, the signal here, is actually an object. And so you could do .value, or you could do .value equals to assign a new value to the signal. So we're writing count.value ×2 to derive that inside of a computed signal. And we're going to write in use signal effect here because we want to demonstrate that we can monitor changes to the signal. We'll come back to that in a minute. All right, before I continue here, let's go ahead and render this so we can start to see what this looks like. We're going to render good counter. All right, now let's go ahead and print out count. Now we could write count.value here, but Preact actually provides an optimization if you just reference the signal directly inside of the expression, so we'll just go ahead and do that. All right, so we're printing it out. Now we just have to add the button. We can write count.value ++ because we're basically saying take count.value and do that plus 1 and assign it to count.value. So this is a shorthand. Very nice. I think I have one too many of those. There we go. All right. Let's see if this is working. Yes, we can click increment. We can see that the value is updating and our derived value is updating. Now, remember that use signal effect little bit I wrote in there? Let's see what that means. So up here in the bad counter, we saw that we could write a console.log and it re-executed every time. Let's do the same thing here. Is this re-executing, right? In the normal world of hooks, state, etc., good counter would execute every single time there's a state change, so we'd expect this console log to rerun every single time. So let's find out. Click, 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 click. Well, doesn't appear to be doing that, right? Let's change this so the code pen reloads. Everything reloads. Is this re-executing? So that runs once, but every single time we click here, nothing happens. That's because our changes to signal values are triggering re-renders, but the entire function is not being re-executed. Only the click handler is running, which increments the value of the signal, and because the value of the signal changes, there's an effect that runs in the background inside of Preact's rendering system, and that effect triggers a re-rendering of only where that signal value gets used, which we can see here is count, and then double as a derived signal value. Now, with use signal effect, we can actually do something that runs every single time. Now, you see here, I have a console log that's blank. Let's just write in, nonsense, right? This will run once, and it still won't run ever again. And the reason for that is we're not referencing a signal. It doesn't know which signal should trigger this effect to rerun. We haven't set up a subscription. So let's go ahead and do that. So we're going to log that, and then we're going to pull in signal.value, or sorry, count.value as that signal value. All right, so let's go ahead and clear this. Right, so bad counter executes. Is this re-executing? Executes. We can write effects on signal updates 0. And we know if we click increment up here, it's going to keep logging. But if we click increment down here, ho-ho, here's where the magic happens, because is this re-executing doesn't run again, because good counter as a function doesn't run again. But the code inside of this signal effect, in this callback, this runs again because we've referenced count.value, which under the hood sets up a subscription. So this callback, this little callback function that we're passing a use signal effect, it gets rerun because now we have a subscription to this signal. And every time we update the value, it is now printing out to console.log. Pretty cool, pretty cool. But wait, there's more. What if you want to have a signal that was defined outside of the component? In other words, it's not internal component state, it's state that's been set up outside of the component. Does that work? Well, let's try it. All right, we're gonna go ahead and create a new signal up here, just a regular old signal using just the basic signal API. All right, we now have outside count starting at 0. And down here, we're going to add another button. All right, but clicking on it won't do anything yet because we're not displaying it. So let's go ahead and add that here. All right, we have outside count. Let's go ahead and spiffy this up just a little bit here in the CSS. so we can see these counters more easily. Let's bump this up a bit. All right, there we go. All right, so we can see that up there. We can see our internal state updating. And now we have some outer state that's updating. Now, how do we prove that this outer state is updating? Before we get there, notice that our signal effect here isn't rerunning when this outside signal changes, right? Because we're not referencing it. It hasn't been subscribed to inside of the callback. And also this console log, of course, still isn't re-executing. Now, if we added additional subscriptions here by adding it to console.log, let's log outside count as well. Dot value. All right, now either time the signal changes, we can see that getting logged. Cool. So let's prove that this outside state is truly outside state and it could be shared across multiple components. Let's go ahead and add a fragment here. And we'll add a second good counter. All right, so now we have two of them. They're multiplying. All right, we have a signal up here. It's updating its internal state to that component. Good. We have another one. But watch what happens now with outside state. Woohoo! Now let's go ahead and see what's going on with the console log, because you can see here we get one printout from this component, right? 12 and 17, which mirrors this and this. And up here, right? 24 and 17, right? But now watch what happens when we increment the outside signal. Oh-ho! We get two printouts of console.log because we have two different components, both of which have subscribed to this outside signal. And so whenever that signal value changes, not only do both components re-render, but both of our own custom signal effects re-execute. So we get two console.logs, one of which is the first component, 24, as you can see, and the next one is 12, as you can see, and then the outside state's both 18. So we're really starting to see here how by reasoning around signals and effects, you can really begin to create all kinds of very specific state changes that do very specific targeted re-renders, these sort of little micro interactivity bits affecting those components without having to sort of like do this whole top-down re-render. Like the whole world has to re-render now. All the functions have to execute, and we have to kind of think about the rule of hooks in the traditional React sense to make any of that work effectively. Let's go ahead and make this even a little bit slicker by changing this fragment with a couple of the good counters into an actual wrapper component, and then we can pass our outside signal as a prop. Let's see if that works as a final exercise here with outside state. Let's write outside counters. And we'll move this up here. And we'll change it to use signal. We'll just say global count. How's that? Global count equals we'll write that a couple of times. All right, now let's accept our props, and we'll change this to props dot global count. And we'll change the incrementer to props.global count.value++. And now let's change this to, what do we call it? Outside counters. Let's see. We're missing something here. Oh, there we go. We need to change this to props.global count. Okay. Okay. This looks promising. So let's clear this. All right. That's updating independently. That's updating independently. But hey, we still have our global count coming from the outside. But this isn't coming from the outside by virtue of just, how JavaScript scope and closures work, whatever. This is coming directly as a prop that's been passed down from a parent. Now, this is the part where some diehard React fans are going to start flipping lids because they're thinking, wait a minute. Wait a minute here. Are you telling me that you can trigger data to, state changes in parent components by things happening in child components, right? Like, are we passing state up the chain instead of just down? Isn't this gonna ruin everything? I mean, it can if you want to go crazy. The tool does not stop you, right? Like up here in our parent, we could have, a reference to this signal. Yo, boom. We are doing some pretty wild stuff here by changing the value of the parent signal down in a child component, and then it's triggering a re-render of these other places that are referencing the same signal, and it's all synchronized. But again, I would like to reiterate something here, right? We're not re-rendering the entire component tree here. We're not re-rendering outside counters. We're not re-rendering two good counter instances, right? We are simply assigning a signal value to a little piece of DOM that gets rendered out in a few places. And when the signal updates, it triggers an effect inside of Preact. And inside of Preact, that effect then updates the DOM just right there. State change, re-render, state change, re-render, but just in that little piece of DOM. The entire component doesn't re-render. And that's why you can write some really performant code and some actually pretty easy to reason about code using signals, even inside of a paradigm that's like React, Preact, what have you. And in closing, I want to do something even crazier. I want to see if we can basically write some vanilla JavaScript inside of, let's say, outside counters to actually update something in the DOM. This has nothing to do with Preact, right? We're not doing anything inside of a component using Preact's API. We're just going to write some completely vanilla JavaScript that will essentially use signals to update some DOM the way we might anywhere. And we're going to see how that works. So let's do that by adding in some more HTML up here. And we'll make it real clear by styling it green. All right, blank div. All right, we are going to use signal effect. All right, I'm just going to write some totally standard vanilla JavaScript. We're going to query the selector. And so text content equals outside count dot value. Let's make this big as well. Okay, so we have a green 0 here, so something rendered. Would you look at that? I mean, how cool is that? We have completely vanilla JavaScript inside of a Preact component, updating a DOM element with the value of a signal. This is just so easy, folks. It's so easy to work with signals and effects to turn your HTML web page into a reactive UI. And this is really the power of signals, because as a primitive, you can use signals everywhere. You can use effects everywhere. They can be added to all sorts of different frameworks, different libraries. You can write completely vanilla web components, then use signals to handle rendering inside of the component. You can create context sort of paradigms, right? Where you pass down context as a global page state, whatever, whether somebody's logged in, who the user is, and then, act on that, react to those changes. I've seen cross-framework usage of signals, right? Where lit as a wrapper around web components, lit could use Preact signals. So you could have a page where you have Preact mounted here and lit mounted over there with some different components and share state between the two just by using some signals. There's so much you can do, and it really makes it so much easier to reason about, okay, what will happen if this state changes? If this state updates, what actually happens? And it's very easy to describe that based on the kind of effects that get rerun because of those signal changes. And I just really love the fact that, you can start out using signals by using them in your favorite, popular JavaScript framework of choice, whether that's Preact or Solid or Svelte's coming out with a signal sort of thing. I think they're called runes. Angular switching to signals. Like, so many different UI frameworks are using signals now. There's even a version of signals that can be used inside of React, which I haven't spent much time with, but that is a thing. So you can use signals inside of, your favorite flavor of JavaScript UI framework now. But then if you want to sort of exit stage, if you want to eject from that world and start to, write more vanilla JavaScript, write some of your own vanilla libraries, you could still take advantage of all of these wonderful benefits of signals in that code as well. So I hope you enjoyed today's look at signals, using them in Preact, showing how you can have multiple components share global state. Global meaning it's been passed down from a parent component. I showed how you can update DOM in a completely vanilla way whenever a signal changes. And there's a lot you can do here. So I encourage you to check that out. There's a link next to this video to the code pen showing off some of this stuff. And I encourage you to play around with that, try some different techniques, different paradigms. And of course, if you have any questions, please head over to spicyweb.dev, join the Discord, and ask me questions there. All right, everybody, until the next Spicy Web video, I hope you take care. Bye-bye.